Let's start our work with logarithms by taking a quick glance at how you change from logarithmic to exponential form and talk a little bit about why we care about doing this. So let's use a first example. If you have log base 3 of the number 4, that's what's inside the log, is equal to x, then we can convert this by bringing the 3 over the x on its shoulders, and it's going to equal to what it's inside. So we say 3, sorry I lost my pen, 3, oh Lord, raised to the x is equal to what's inside, which is 4. Try it again with another one, and let's call this b. And we say log base 10 of x is equal to 5. Now here is why you see it's important. Over here, x is equal to just a number, so converting it is silly. But on this side, the variable is stuck inside, and the only way to get that variable out from inside of that logarithm is to convert it to exponential form by bringing the 10 over, let the 5 be its exponent. That's going to equal what's inside. So 10 comes over, raises the 5 on its shoulders, and equals what's inside, which is x. So 10 to the 5th is equal to x. So we could actually find what x is. We can go the other way, which is the next one, translating from exponential to logarithmic. And we see for the first example why that's important, and we're going to go backwards. If we have 3 to the x is equal to 5, for this one, we can't equate the bases to pull off congruent or the exponents to make them equal to each other, which is one of our favorite ways of solving problems that have variables in the exponent. And so our only possibility at this point is to be able to convert back to logarithmic form again. So the base is the base of this exponent over here, exponential function. The x is what goes on the other side, and then the 5 is what ends up inside. Puts it right back again. Let's do that again. And for this one, 2 to the x is equal to 5. So the 2 is the base, so the 2 is going to be the base of the logarithm, so log base 2. We're going to put something inside. This x is what comes over here, and then the 5 goes inside. Now, you can use your calculator by hitting, if this is a base 10, hitting log base 10 and putting the number in. But when you've got this guy sitting here, in a few minutes we're going to take a look at how can we actually evaluate this, because as it is here, your calculator doesn't know what to do with it. So evaluating logarithmic functions by equating exponents. So what that means is that we've got a function. Let's call it log base 2 of 8 is equal to b. We can't use our calculator for that because your calculator does not know how to do log base 2. So we're going to convert to exponential and do 2 to the b equals 8. Now we know what's coming. 2 to the b, 8 can be written as 2 cubed, so we're going to be able to then make those exponents, pull those exponents off and set them equal to each other. Sorry. 2 to the b is equal to 8, so 2 to the b is equal to 2 cubed, because 8 is 2 cubed, so you get b is equal to 3. Very nice. Let's do that again. You can try this one. b log base 3 of the square root of 3 is equal to b. Now we have a couple different ways of doing this. We're going to do this one by equating exponents. So we're going to convert it to exponential notation, raise the 3 to the b is equal to the square root of 3. Square root of 3 is 3 to the 1/2. So pull those exponents off, b is equal to 1/2, and then you're done. You can also solve equations in this same way, and to do that, we're going to end up getting some functions who end up with this, and then in a little bit we'll figure out what to do with that. In fact, why don't I just show you that now? Make this page a little bigger. Okay. when you have something, it's called change of base. This is a handy conversion when you have log base 2 of 3, that is equal to the log base 10 of 3 over the log of 2. And so what's inside, take the log of that in the numerator, what the base is, the log of that in the denominator. Both of these are log base 10. Remember, when you don't actually write a base in, it's common log, which is 10. And you can use your calculator for that. Just be careful to use parentheses so it doesn't get confused. So when you're solving equations and you get down to this, you can then do a conversion doing this and get the variable solution that way. Or you can equate exponents for this one. So you're going to have some options for these. And we'll solve some more problems in a minute. So let's go down and practice a couple of these. Go ahead and do number 1 and number 2. Pause the video and come back. Can you convert each of those? Remember, the base of this term becomes the base of the logarithm, so your log base 5 of something is equal to what that exponent was, and then what it was equal to is what goes inside the logarithm. For the other side, you can put it back again, so you have log base 3 of something is equal to 4, and that something is going to be what's on the other side. Okay, for the next one, you're going in the other direction. I find this direction a lot easier, where you're going to convert back into exponential from logarithmic form. And so let's go ahead and do 7 and 8. So for 7, the 2 lifts the 3 on its shoulders, and it equals what's inside. So 2 cubed is equal to 8. When you come over here, 3 to the 5th is equal to 243. So what we care about is actually trying to solve equations eventually. So let's use your calculator. Here it says, let me get my highlighter tool, by equating exponents. So don't get your calculator yet. Let's do a couple of these. Let's do 13, 18, and 16. For 13, set this equal to b. Then it's 6 to the b is equal to 36. So 6 raised to the b, 36 is 6 squared. So we can go ahead and pull those exponents off and get, boy, that looks like a 6. B is equal to 2. Go over and do number 18. Whoa. Go over and do number 18. Set this equal to b. So 8 to the b is equal to 2. 8 raised to the b is equal to 2. Well, let's go ahead and rewrite 8. 8 is 2 cubed raised to the b. Still equal to 2. Multiply that 3 in b, so you get, that's a 3. 2 to the 3b is equal to 2 to the first, which means that 3b is equal to 1 because the 2 has an exponent of 1. So b is equal to 1/3. Weird, right? That's okay, though. You can get a fraction. You don't have to have integer answers for each of these. Let's look at number 16. Set this guy equal to b. 2 raised to the b is equal to 1/2. Let's write that. 2 raised to the b equal to 1/2. But you know that 1 over 2 is really 2 to the negative 1. So you can pull those exponents off. B is equal to negative 1. So you can also get negative answers. You can get integer answers, negative answers, and fractional answers, and they're all will work for you. Okay, let's go down now and solve a couple of equations. So number 29, solve each of the following equations, write your solution in terms of a logarithm. Okay, so that means don't simplify, don't use your calculator. We're going to write this in logarithmic form. the base of this expression on the left becomes the base of the logarithm. Log base 2 of something is equal to the x, and what goes inside is what was over here on the right. And we're done there because this x is by itself. That means you have solved for x. Let's go down to the next one. This one's going to take a little bit more work. We're still going to go ahead and do that conversion here. We're going to use the 4 as the base of the logarithm, so log base 4 of is equal to, sorry, go ahead and write of the other side is equal to the exponent is equal to 2x. We're trying to solve for x, so let's divide both sides by 2. That's going to give us x is equal to log base 4 of 13 all divided by 2. And you can also write that as 1/2 log base 4 of 13. Either of those is correct, but you got to get the x by himself, so make sure that you do that. And let's go ahead and look at 33. It says approximate the solution to each of the following equations. Remember the ln. Remember, we don't say ln, we say natural log. That means it's a base e, and when it's a common log, it's base 10. So let's look at 33. First, we have to get, before we do any conversions, we have to get that exponential by itself. So let's divide by 10. You get e raised to the 0.01x is equal to, and simplify that, 25 over 10. 5 goes into 5. 25 5 times into 10 2 times. Now let's go ahead and do the conversion. The e becomes the base of the logarithm, so it's the natural log, which is base e, of the other side, 5 over 2, is equal to the exponent, 0.01x. We have to get that x by itself, so let's divide by both sides by 0.01. That gives us x is equal to the natural log of 5 over 2 divided by 0.01, but when you divide by 0.01, and it says approximate each of these to the nearest thousand, so we don't even have to do any simplification. Let's use our calculators. You're going to enter, hit the natural log key, you'll get ln with a parentheses. Type in 5 divided by 2, end the parentheses, then hit the division sign 0.01. And when you do that, you are going to get approximately 91.63 to the nearest hundredth. Your worksheet should say hundredth. I'm not sure. I don't have that in front of me. So if it's thousands, take it to the next one. Let's go ahead and do the next guy, 34. For this one, it's already simplified. You've got your exponential piece here without any coefficient in front. And so let's go ahead and convert that. We get log base 10 of 30 is equal to x. Check by going backwards. This is base 10. 10 to the x equals 30. That's what this says. Then just use your calculator. You're going to hit the common log. So log, type in 30 and parentheses. And what's it tell you? X is about equal to 1.4. And if it's to the nearest 110th, it's 48. If it's to the nearest thousands, it's 1.477. Again, go by whatever the instructions are telling you on the sheet in front of you. So that's it. Hope you're having a great day.